Hey, I'm Ian. Today we're going to be doing problem number 45 from page 76. So this problem reads, a car travels due east with a speed of 50 kilometers per hour. So here we have our car traveling east at 50 kilometers per hour. So, rain is falling vertically relative to the earth. So we have rain falling down at a 90-degree angle. When the rain hits the windows on the car, it leaves streaks at 60 degrees. So what we need to find out now is A, the velocity of the rain relative to the car. And next, we're going to find out the velocity of the rain relative to the ground. So, we can take our window here, or 60 degrees from the window, and the 50 kilometers per hour from the velocity of the car. We draw a right triangle. So here we have the rain coming down at 60 degrees to the window. And we have the car going 50 kilometers per hour east. Okay, so now to find the velocity of the rain relative to the car, you will be looking for the hypotenuse of this right triangle. So to do that, we can take the sine of the angle 60 degrees over here, and we can take, because sine is opposite over hypotenuse, we will take 50 kilometers an hour divide that by our hypotenuse, which we're going to label V. V with subscript R for rain. So we can multiply both sides by V subscript R and divide both sides by sine of 60. So for the left side we get V of R, we get VR, and on the right side we get 50 kilometers per hour over sine of 60. Now when you put that into the calculator, you get a reading of 57.735 kilometers per hour. Now we want our units for velocity to be in meters per second. So we're going to multiply this by 1,000 to convert it to meters, and then divide by 60 to convert from hours to minutes, and then 60 again from minutes to seconds. And we'll get a value of 16.038 meters per second. So for A, we have value 16.038 meters per second. So now, if we erase the work for part A, we can do part B. And we're finding the velocity of the rain relative to the ground. So here, we're trying to find y velocity moving downwards. So we now can take our tangent, because we already have the base of 50 opposite, and we're looking for adjacent y. So we take tangent of 60 equals 50 kilometers per hour over velocity of y in the y direction going down. So now we have multiply both sides by velocity in the y direction. We divide both sides by tangent of 60. So we have velocity in the y direction equals 50 kilometers per hour, all of that over tangent of 60. Now when you plug this into the calculator, you get a value of 28.868 kilometers per hour. But once again, we would like to have our answers in meters per second. So we're gonna multiply by 1,000 to get meters, and divide by 60 twice to get seconds. And when you calculate that, you get a total of 8.019 meters per second. So now we have A, velocity relative to the car, a speed of 16.038 meters per second at direction of 60 degrees from 60 degrees to the left of the y-axis. And we have answer B, velocity relative to the ground, which is 8.019 meters per second perpendicular to the ground. So that's it for this problem. I'm Ian Liu, and I'll see you next time.